Hey there, Michael. I'm looking at basically trying to think of a good way to look at this problem. And so I've color coded the three sections of the bike that we're talking about. So this section here in red, that's going to be the pedal sprocket, and then we've got the back tire sprocket, and then we have the back tire. And so as we'll see, let's see if I can. That's better. As we'll see, we have different measurements on each of the sprockets in circular and wheels. So the wheel has a measurement that is the radius of 14 inches. Therefore, its circumference is 28 pi. The pedal sprocket has a radius of 4 inches. Therefore, it is 8 pi. And then the back wheel sprocket has a radius of 2 inches. Therefore, its circumference is 4 pi. So the first thing that we're asked to do is to find the speed of the bicycle in feet per second and miles per hour. So the speed of the bicycle is dependent on, I didn't write this information down, but we were told that the red sprocket or the pedal sprocket goes one revolution, let me use red, goes one revolution per second. Okay, so that's how this guy is traveling. So here's the deal. If the cyclist is biking one revolution per second, one revolution of this guy, one revolution that goes 8 pi inches, is going to be two revolutions for this guy. All right, so the smaller sprocket goes around twice in 1 second. So I'm going to write that down. And I'm getting that just by the circumferences. So the circumference is going to be the revolution is going to be 2 revolutions per second. This is pretty necessary information. Then the next piece, and this is tricky, I'm going to go back up to the picture. This sprocket is attached to the bike, to the bike's back tire, such that as this guy turns, this guy turns. The revolution, the take home point that I want to make is that the revolution of the yellow circle is the same as the revolution here. The reason why is because these are intrinsically tied together. So however this guy turns, this guy turns. Does that make sense? I hope that makes sense. So let's think about that. So since this guy is going 2 revolutions per second, the tire, this big old blue tire, is going 2 revolutions per second. And that's just how a bike is made in the relationship between the back sprocket and the bicycle tire. So now that we've got some information of how far, now we're going to use this to get information about how far the bike is traveling in reference to time. So if the tire goes 2 revolutions per second, that means it travels a distance of 28 pi inches per second. No, just kidding. It travels 28 pi inches times 2 per second because it goes 2 revolutions per second. So I'm going to start off with that information. So I've got 2 times 28 pi inches over seconds. Pause me if you need to. Think about what that's like. Think about why that's true. So I'm going to write that a little bit differently. Try to write neat here. 56 pi inches per second. Now we're going to use some, what is it called, dimensional analysis. You used it in chemistry where you had to change like units and all that stuff. So they didn't ask for it in inches per second, which is what we have in it, have the units that we have it in. We need to find the speed of the bike in feet per second. So to change my inches to feet, I'm simply going to multiply 1 foot over 12 inches. Do you remember this kind of business? You would probably just tell me, just divide it by 12, and you're right. So when I divide 56 by 12, 12 obviously doesn't go in evenly, but I get 12 goes, I can divide both of these by 4, and then I get 14 pi over 3, and that's feet per second, and you'll see that in the back of the text. But that didn't answer both parts of the question because really we have it in feet per second now. Now we want to change it to miles per hour. And again, we're going to use a little bit more dimensional analysis. So I'm going to start off, let me scooch this up a little bit. I'm going to start off with, so we're changing feet per second into miles per hour. Dimensional analysis tells us that first let's deal with the feet. I can say, okay, if I'm going to change from feet to second, I'm going to go, well, I know that 1 mile is the same as 5,280 feet. So that little bit of information is going to change my feet to miles, but now I've got to change my seconds to hours. And then so what I would do is I'd multiply 3,600 seconds is equal to seconds. Let's make that like SEC is equal to 1 hour. So when I do the math here, I'm going to end up multiplying 14 pi times 3,600 divided by 3 divided by 5,280. And in the end of all of this, and I've checked it, we get approximately 10, like 9.995, blah, 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 blah. We get 10 miles per hour. So that's how you would process through this piece. So the next couple of questions, let's take a look at those, parts B and C. So use the result from part A to write a function for the distance d in miles of a cyclist traveling in terms of the number n of revolutions of the pedal sprocket. So thinking about this, if the pedal sprocket, right? Remember the pedal sprocket we're doing in n. So if there are n, I thought I grabbed the red one. If we have n revolutions, right? And so this n refers specifically to the pedal sprocket. If I bike and if I turn this n times, how far will the bike travel? And they want that in miles per hour. So I know if it turns n times, that means the actual bike tire turns 2n times. Remember that whole thing where we compared this radius to, this circumference to this circumference? We recognize that this circumference, the revolutions here, these will be twice as fast, but since this is connected to the bike, it makes the bike go twice as fast as these revolutions. All right, stay with me. So we have 2n for the number of revolutions that the bike tire travels, and we know for each 2n of those revolutions, the bike tire will travel 28, so that's going to be 2n times 28 pi, right? That's the number of revolutions, and that's the distance, and that's going to be inches. So this is the distance, but the distance is supposed to be in miles. So now we've got to change this to miles. How do we change, because all of this is now in inches, how do we change inches to miles? Well, we're going to first change our inches to feet. And I'm going to do that by multiplying 1 foot over 12 inches. More of that dimensional analysis business. But then I'm going to take, now 1 foot over 12 inches, now these guys will cross out. When I multiply all that together, dividing by the 12, I'm going to have this answer in feet. Now I got to change my feet into miles. And I do that by saying that 1 mile is the same as 5,280 feet. I know that's real terrible there. I'm going to write it a little bit better underneath. So here is the big to do. The problem says D, the distance, is equal to 2 times n. So for every n revolutions of the red sprocket, I get 2n revolutions of a tire that is 28 pi circumference in inches. We need it not to be in inches, so I'm going to change that by doing 1 foot. Say hi, Lily. All right, baby. So I've got 1 foot for 12 inches, and then I'm going to change that to, from inches, I'm going to go to miles. From feet, I'm going to go to miles. So 1 mile changes to 5,280 feet. Let me pause this. Okay, so this should be 5,200 and let's get this pen here, and 80. Okay, I know this is taking forever, but it will make sense. So we do the 2 times that, we get 56 pi n times n, all of that over 12 times 5,280. And when we reduce this and we do some good math, dividing the top and bottom by, 4, and we break it down, we're going to end up with 7 pi n over, I think it's 7,290, something like that. And this is actually the answer in the back of your book. So okay, so I mean that is how we get that answer. And the next piece that I want to talk about is that third question. And the third question is actually a little bit simpler than it might seem. So what I want you to think about, or what I want you to realize, is that shh, Lily. So what I want you to think about is, if you remember in the beginning, for each one revolution, there is 1 second, right? So for each one revolution of the red sprocket, there's 1 second that transpires. So for every revolution, there's 1 second. So even if there's n revolutions, it would be n seconds. So what this tells us is, from that equation that we had from that last problem that I think I somehow erased, we ended up with the distance is equal to 7 pi n over 7,290. The n can be replaced with t, because if t is seconds, right? For every second that transpires, we are going to travel this distance. So d is equal to, so for part C, the answer is d is equal to 7 pi t, pardon me. Sorry, I got some restless children here. 7 pi t divided by 7,290. And so these are your two equations. And they ask in part D, what's the relationship between the two equations? And basically the relationship is that the equations are the same. Your text says that the equations are linear, which they are. This 7 pi over 7,290 is just a linear equation. I think I'm going to stop here. I hope that was kind of helpful. I'm interested in hearing how your teacher goes through it, and I look forward to talking to you soon. Have a good evening, dear. Good night.